So the species we're going to be focusing on today is going to be the nitrite ion, and I'm going to be showing you how to do a Lewis structure. So before you actually start drawing it, you have to figure out how many valence electrons there are, and we can do that by adding up the group numbers. So for nitrogen, it's going to be group number 5A, so we're going to be focusing on number 5. Oxygen is going to be group number 6A, so number 6. So we have 2 oxygens, so that's 6 times 2, it's going to be 12. 12 plus 5 is 17. That's an odd number, but we have an extra electron right here, so add that one. It gives us 18 valence electrons. So the central atom is going to be nitrogen because it is the least electronegative. So I'm going to draw 2 terminal oxygens, and then we're going to start by adding the electrons. And we soon find out that there's an issue that does not follow the octet rule. So I'm going to erase those. We're going to double bond this oxygen right here to do 2 lone pairs, and we're still going to keep 3 lone pairs on this, but that's only 16, so we add 2 more here. And how I got that was each of these bonds represent 2, and there's 3 of them, so that equals 6 pairs right there. Each lone pair is equal to 2 electrons, and we have 1, 2, 3, 4, 5, 6. 12 plus 6 equals 18. So this may look like a complete Lewis structure, but it is not, because we have this electron up here. That is part of the ion, which creates the nitrate ion. So you have to do a bracket around the structure, like so, and then add the equivalent electron to create an ionic compound. So this is the electron pair geometry for nitrate ion. As you can see, it's going to be a trigonal planar. So when it's flat, it's going to be on a flat surface. It's going to be looking like this. The ideal bond angle is going to be 120 degrees. That is known because of Vesper theory. Basically, Vesper theory is saying that electrons have repulsive forces. So at the ideal bond angle, they are far enough away, but they're also not too close enough to where they could interact with each other. So molecular shape is going to be a little different. It's going to look like this, mostly because it does not take into account lone electron pairs. Because as you saw in the Lewis structure, there were a lone pair of electrons on the nitrogen atom. So you take those away, and we're left with a bent molecular shape. And this would be a polar bond because of that lone pair of electrons on the central atom.